rational functions, exponential and logarithmic functions, and we're starting with the rational functions. Okay, so starting with the rational functions, let's describe the parent function. So function family.
Recording?
I did.
Okay.
Yeah, it's okay. Function family is rational. What is the parent function for rational function? What is the simplest rational function? Where is s? What is the definition of rational function? When we have x in the denominator, rational always means fraction, right? So we want the x in the denominator. So 1 over x is the simplest one. Let's graph it. We'll just use calculator. You don't have to, if you remember how the function looks approximately, you can do the table, but we'll just graph it. So graph, y equals 1 divided by x. Graph. Once you graph the function on your calculator, on the test obviously you want to be not very precise, but approximately precise, right? So do make sure to note anything interesting about the function and then take like 3 points on both sides of the vertex or asymptote or something, right? Of the center to make sure that your function is where it's supposed to be. So what I'm going to do is I'm going to take the table, find the center which is at 0, and then just take this table as my reference. I know how the function should look, so all I want is to get some good points. -1 is 1 point, -2 half, and then I know that my function will look something like this, right? And on the other side, 1, 1, 2 half, and then I see how as x grows, the y becomes less and less, gets closer and closer to 0. So here is the second upper bound. So what is so interesting about this function? We have these two parts. Do we have asymptotes? Yes. Horizontal or vertical or both? Both. So let's talk about the vertical asymptote first. Asymptote is the line that you get very close to but never touch or never cross. In the case of parent function, obviously everything is super simple and super nice. So my vertical asymptote is what?
0, 0?
Don't just give me numbers, give me the equation. Is it y or x? X equals 0. So my vertical asymptote, yes, x equals 0.
And then
Vertical asymptote is x equals 0. And then my horizontal asymptote is what?
y equals 0?
My horizontal asymptote is very good. So which one, vertical or horizontal asymptote, is related to domain? Vertical asymptote, right? Because vertical asymptote divides the function, so we are kind of excluding that x from the domain, right? The one that we cannot touch or cross, right? So my domain will be what? Either in the interval notation -infinity to 0, union 0 to positive infinity, or you could also write the domain in the set builder notation, all x such that x not equal to your vertical asymptote value. In our case it's 0. Perfect. What about range?
Is it much like how you would write the domain?
You can see that as I start moving from the bottom to the top, right, and figuring out where my function exists, it exists everywhere except I never touch or cross my horizontal asymptote, so I will never have a point on my graph that will have y equals 0, right? So it means that the range will be negative infinity 0, union 0, positive infinity, and I get that 0 from horizontal asymptotes. So let's write it, exclude vertical asymptote for the domain, exclude horizontal asymptote for the range. Remember that we could also write the range in set-builder notation, all y such that y not equal.
There are no zeros, right?
Yes, zeros and x-intercepts are obviously the same thing, and we don't have any because we never touch or cross our asymptote, and in this case of the parent function, the asymptote is actually x-axis. So none, none.
What about y-intercepts?
What about y-intercept? Do we ever cross y-axis?
No.
No, because it is our vertical asymptote. So for the parent function, none.
Okay.
Okay, where is my function increasing? As I move from the left to the right, do I ever go up? No, I always go down. So my function increases nowhere, none. What about decreasing?
Yes?
Yes, my function always decreases, right? As I move from left to the right, I always go down, even though it looks like I'm going just like straight to the right, I actually do move down. It's just the change is so small that you cannot see it with the naked eye here. So what do I write for the decreasing integral? Domain. Don't write negative infinity to infinity. If I say my function decreases everywhere, what I mean is everywhere where it's defined on its domains. Right. So interval of decrease, I just copy the domain. Negative infinity to 0 and 0 to infinity. And behaviors. What happens as I go to the right? Yes, I go to the right, x increases to the positive infinity, my y gets stuck, my function is stuck very close to my asymptote. So remember our ha-ha? Yeah, ha-ha for right and left behaviors. Same happens as I go to the left. 0, 0. Horizontal asymptote, ha-ha. Any questions about this? Perfect. Let's look at some of the transformations, right? Select the best description for the range of the function shown. Okay, two ways to do this. We are talking about range, so it's all about y values. First, I could just graph it, right? And figure out my horizontal. Okay, so which one is important for me for the range? Horizontal asymptote or vertical asymptote?
Horizontal.
Horizontal, right? I want to see how my function is divided horizontally, because y changes vertically, vertically, so yeah, horizontally. So how do I figure out what is the horizontal asymptote for this function? Two ways to do this. What is the easier way, or what is one way?
The graph.
Horizontal asymptote. First of all, I can look at the graph. Let's look at the graph. X plus 5 by x minus 2.
Graph is kind of wonky.
Let's see. So y equals here. Don't forget parentheses. X plus 5 divided by x minus 2. Okay. Okay, so I'm looking for my horizontal asymptote. It looks that it's somewhere around 1, maybe 2, but more likely 1, right?
No, it's on 2 for mine.
Is it on 2?
Yeah, because I did a little
So
running.
if the graph, I mean, I can approximately see where the horizontal asymptote is, but how do I make sure that I'm not off?
Oh, I have a line over
Huh?
here. I have a line.
Yeah, we get a line.
Oh, you get a line?
That-
Perfect.
That's
If you
right here.
all calculators show the line?
No, it's just some of the new.
Right. Okay, so if I'm not sure, what can I do in my calculator to figure out what the asymptote is?
You can.
I can go to my table, right? And my horizontal asymptote is the same as my right and left behaviors. Remember? So if I scroll all the way to up, and my x goes to negative infinity, right? So if I go like far, like negative, I don't know, 50, see what's happening to y? Okay, it gets up, higher, 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 but it doesn't seem to reach 1 ever.
We won't reach 1, will it?
I don't think so, right? What it means is that my left end behavior seems to be 1. That should be my horizontal asymptote value. See what's happening? It gets very close to 1, but it never reaches 1. So, as it does this sin, because I wasn't careful enough, I can, figure out that y equals 1 is my horizontal asymptote based on left or right end behavior. Or, if you don't want to do that, you could also figure it out algebraically. How do we do that? For horizontal asymptote, we need to look at the numerator and denominator, remember, and compare the highest exponent for x. So in this case, this is quite simple. X to the power of 1 is the highest exponent on x in numerator. 1 is the highest exponent on x in denominator. So what I'm looking at is the coefficients, the leading coefficients of these two polynomials, right? 1 divided by 1 is 1. That's how I know that y equals 1 is, so correct how we did this equation. So horizontal asymptote compare to highest exponents of numerator and denominator. And look at leading coefficients. Right? In my case, it's 1 divided by 1. That's my horizontal asymptote. No, for sure. So, since horizontal asymptote is y equals 1, what is my range? Everything except 1. Answer is simple. Perfect. Questions? Okay. Next. Identify the equation of the horizontal asymptote and the equation of the vertical asymptote of these rational functions. Choose from the options below, write the correct answer for each asymptote in the box. Perfect. Horizontal asymptote, since we talked about it just now, how do I figure out horizontal asymptote just by looking at this function? It's y equals what? 3 divided by 1, right? It's 3 divided by 1 because the highest exponents are the same. I'm looking at the leading coefficients. So y equals 3 should probably be my horizontal asymptote. Y equals 3 right here. Done. You can also look at the graph based on right and left hand behaviors to figure out the same information. Vertical asymptote. How do we figure out what vertical asymptote is? 2 ways. Algebraically, set denominator to 0. Right? Because why? Vertical asymptotes eliminate some of the values for x. So it's the problematic x's. What can be problematic here? Denominator 0. Right? That's the domain restriction. So x plus 4 equals 0. I solve for x. Minus 4 gives me x equals negative 4. Negative 3. But
You said the numerator equals 0.
Denominator.
You said the denominator equals 0 on the vertical.
Yes.
What about the horizontal?
Compare the highest exponent. And then the leading
Then you
coefficients.
choose the highest exponent of the leading coefficient.
Leading coefficients of the highest exponents. So if I forgot or wasn't sure about the algebraic way to figuring out vertical asymptote, what can I do when I look at my graph? How do I figure out in my graph what the vertical asymptote is? I can go to my table and what am I looking for?
Red,
vertical asymptotes. Remember, we have a vertical asymptote somewhere here, and then my hyperbola looks like this. What will I see in the data table for this value of x? Error. Vertical asymptote, domain restriction, error. Right? Domain restriction is everything that gives me error. Okay? Make sense? Luis? Good? Okay. Do you want to look at the graph or not?
Yeah, let's look at that.
Let's just look at this one. Right? So if I had this one, how do I figure out what my vertical asymptote here is? I go to my table and I'm looking for errors. Okay, somebody told me how to do this today and I forgot already. 62 equals. This was burned. How to get 0? I'm so far from 0. How do I get to 0? So plus negative.
You go to table set. You do it as, I guess.
You're searching for 62 and 0.
Okay, we continue. So next question, let's look at the next problem. Find the domain of the following function. How do I find the domain? What do I do?
You said you take the
Put it in your
coefficient.
calculator.
I can do two things. Algebraically, I'm looking for the restrictions on domain, which is what? Denominator 0. So algebraically, I would take denominator and set it to 0 and solve for x. Because my denominator is quadratic function, how many domain restrictions will I have?
So the range is where you look for.
Yes.
But the domain is very simple.
Yes. So I expect 2 domain restrictions, which means I should see 2 vertical asymptotes, right? So let's look at the graph. So graph, look for VAs. So I will look at the graph. So graph y equals, clear everything. Please don't forget parentheses. 5x minus 2 parentheses divided parentheses x squared minus 3x minus 10. Close parentheses. So if I look at my graph, I will clearly see where the asymptotes are. See, now we have, instead of just 2 parts of the graph, I have 3 parts of the graph. And so it looks like there are 2 vertical asymptotes as I expected. One right here and one right here. Again, just to make sure that they're not fractions or anything, I could go and check my table. So I'm expecting errors around -2 and positive
5.
maybe 5. Right, so if I go back to my calculator and look at the data table, -2 is error, just as I expected, and let's see around 5. 5 is also error. So that's exactly what I found on my graph. So I don't need to solve it. Sometimes when you have fractions, right, you will not see these values in your calculator. Then you would have to solve your quadratic equation. But in this case, I don't really need to. So what is my domain? All x such that x is not equal -2 or 5. -2 or 5. Make sense? Yes. If you don't see it in the calculator, just solve quadratic equation. Maybe you'll get the action. Also, this is set builder notation. In the other notation, I would say -infinity to -2 union -2 to +5 union 5 to infinity. Right? Because now you have 3 intervals. Can you even see that? Kind of, no? No?
Can you please do it in yellow?
Yellow. How do I find? I don't have
It's right there. It's just hard to see. You picked it.
Okay. So negative infinity to negative 2 union negative 2 to 5 union 5 to positive infinity, right? Because now I have two restrictions, so I need to eliminate both negative 2 and 5. 3 intervals.
So if you have four different intervals, does that mean that there's 3 different things?
Yes.
So every time you have
Okay, next one, the last one on this page. What is the end behavior of f of x equals x minus 5 over x plus 3? How do I know the end behaviors?
if we look at the graph,
We can look at the graph, right? I could also look at the horizontal asymptote and figure it out algebraically. Because we already did this algebraically, we remember that horizontal asymptote is y equals what? Looking at this function. 1 over 1. The highest exponent is 1 in both numerator and denominator, and the leading coefficients are 1, so 1 over 1 equals 1. Since this is my horizontal asymptote, we remember, for the right and left end behaviors, so I know this will be 1 in both cases. Also can look at the graph. Doesn't hurt to double check. Okay, if there are no questions, let's move on.
What do you do with x plus 3?
Huh?
What do you do with x plus 3? Just, you do nothing?
No? This is only for domain and vertical axis. Okay, so rational expression. How do we add and subtract rationals? This is just like working with normal fractions. To add and subtract, you need common denominators. So factor all denominators first, figure out what your least common denominator is, multiply each fraction by the missing factor, and then when subtracting, remember to put the second fraction in parentheses to distribute the negative sign. We'll see the example. Once you have combined your fractions into a single fraction, try to simplify again by factoring, canceling out common factors. Questions? So let's see. Assuming the denominator is not 0, completely simplify the following expression. I have fraction minus fractions. Denominators are exactly the same, so what do? Keep the denominator and then just subtract numerators. Agree? This is like 3/4 of a pizza minus 1/4 of the pizza. 2/4 left, right? Don't do anything weird with the denominators. Don't put 4 times 4. Don't put x minus 3 times x minus 3. It's just 3/4 of a pizza minus 1/4 of a pizza. So keep denominator the same. Add or subtract numerator. So what I put here is 2 minus x. If you see this format of the question in SOL, you just need to recognize that one box is for numerator, one is for this denominator. Look for that fraction.
You can switch it, right? To x minus 2, can you switch it to x minus 2? That.
Negative x plus 2.
You can do negative x plus 2 divided by x minus 3.
It's the same thing.
Yeah. Okay, next, simplify. So now I have this addition of two fractions, denominators are not the same. So what do? Factor denominators. The first one, my m is negative 20, my a is negative 1. So what are my numbers? Negative 5 and positive 4. Perfect. That's my first denominator, factor. What about the second one? 7 and 12, 3 and 4. So x plus 3, x plus 4 is the second denominators in factor form. So I need to look for LCD or make up LCD. So if my first fraction has factors x minus 5 and x plus 4, and my second fraction has the factors x plus 3 and x plus 4, my LCD has to include all the factors. So I see that x plus 4 is included in both, so I'll just copy it down. But the other two are different, I need each of them. So my LCD will have three factors. X minus 5, x plus 3, x plus 4. Agree? Can I read it? So now I'm looking at my fractions. The first one, which factor is missing? X minus 5 is there, x plus 4 is there, x plus 3 is missing. So I need to multiply numerator and denominator by x plus 3. Same for the second fraction. I see that x minus 5 is missing in denominator, so I need to multiply both denominator and numerator by x minus 5. Now the problem becomes much easier. I have two fractions with the same denominator. So I just copy denominator x plus 3, x plus 4, x minus 5. And then I combine my numerators. Since it's plus, nothing to worry about. If it was minus, I need to not forget to distribute that minus into parentheses, right? So for now, for this one easy, 2x plus 6, and then plus 3x minus 15. Simplify numerator, 2x plus 3x is 5x, 6 minus 15 is minus 9, right? Okay, so denominator x plus 3, x plus 4, x minus 5. Cannot do anything because numerator is prime. There is no GCF. Nothing can be done. Nothing can be cancelled out. We're done. That's our answer. Questions? Okay. Okay. Simplify and multiply. Factor everything, every numerator, every denominator. Cancel out factors that are on the top and on the bottom. Let's see. Numerator. What can I do? Dos.
X plus 5.
Good.
So,
So, what is my first parenthesis? X plus 5. And my second parenthesis?
x squared minus 5x plus 25.
Perfect. Perfect. So, same, opposite, always plus. Don't forget. There should be opposite signs. The first two signs are opposite.
Same, opposite, or
Same, opposite, always plus. Okay, now I'm looking for the factors common to both denominator and numerator, and I see 1. X plus 5 cancels out. So the final answer is x minus 5 over x squared minus 5x plus 55.
Would you simplify the x squared integer?
Would I simplify what?
The x squared.
Trinomial on the bottom.
This one?
Yeah.
Right. So if this was not the, if this was different kind of problem, I would definitely try to factor the denominator. Here I don't need to, because I know that whenever I have a solve formula, the second lone parenthesis is prime, always. So you can try, but you will not find any factors. Right.
So anything that you said is not going to be.
No, when you solve, that lone parenthesis is always prime. Both of them are always prime. But if this was different from like multiplication or something, and then I see something like this, always try to simplify it, like your final answer. Next, multiplication problem. So this one is kind of ugly. Lots of work. Okay, let's see. The first numerator, what can I do? Always look for GCF first, right? And remember how we said, if you have the negative in front of the highest exponent, we want to get it out as part of GCF. You see how I have 25 minus 4x squared here? I want to order the terms from the highest exponent to lower one. So I want to rewrite this whole thing as negative 4x squared plus 25. It will help you later. what it might calculate. You see negative in front, I want to get it out. So there is a GCF of -1 and then times 4x squared minus 25. Okay? And now I will recognize that this parenthesis is DOS. Make sense? Okay. So minus, I see that this is DOS. So instead of 4x squared minus 25, I can put what? 2x minus 5, 2x plus 5. Agree? So this whole thing, whatever I'm highlighted, this is my first numerator. Perfect. Divided by. Oh, there is this denominator. Let's do one of them and then I'll just give you answers for the other two. So 6x plus 9 minus 15. What is my GCF first? 3. So 3 comes out. After 3 came out, what I'll have is 2x squared plus 3x minus 5. Agree? Since this is trinomial, I need to do t-chart. So my t-chart is, my m is 2 times -5, -10. My a is 3. What are my numbers? 5 and -2. So because the leading coefficient is not 1, I cannot just immediately use the numbers for my factors. I have to split 2x squared minus 2x plus 5x minus 5. I do the grouping. My first GCF is 2x, x minus 1. My second GCF is 5, x minus 1. When I take x minus 1 out, what is left is 2x plus 5. Okay. So right there, do not forget the GCF. Once you took the GCF out, immediately put it there in the denominator. So 3 times x minus 1, 2x plus 5. This is my first fraction. Let's look at the second fraction. Any questions about this? Okay, second fraction. Do I see GCF in the numerator? 2. So 2 comes out. After I do it, I have to do the same trinomial again and group in because the leading coefficient is not 1. For the sake of time, can I just give you the factors? They're all comfortable, right? So x minus 1 times 3x plus 2. That's my numerator. And after I do pretty much the same thing with the denominator, I'll have 2x minus 5 times x plus 2. So because when we multiply fractions, we multiply numerators and denominators, this whole thing is just like one single fraction, right? And we can cancel out the factors that are in denominator and in numerator. What can I cancel? 2x minus 5 can I cancel? Yes. This is exactly why that negative GCF was important, because if I didn't take it out, I would have it 5 minus 2x. And it wouldn't be the same as 2x minus 5. And that's why it was important for me to get that negative out. 2x plus 5 can be cancelled out as well. X minus 1 can be cancelled out as well. And so what is left? Negative 3x plus 2. Here is the 2, so negative 2, 3x plus 2 is left in the numerator. And in the denominator I have 3x plus 2. Can I cancel out these x plus 2's?
No, you can't.
No, right? There is 3.
The 3 was outside the parentheses.
Yes, exactly. Okay. So I'm done. Here is my answer. Answer C. Perfect. Okay. So maybe we can skip this one. Are we good with this one? What do you think? Yeah? Just like one pointer, don't cancel out both of the x minus y's on the bottom, right? It's just once. You can cancel it out just once, correct? Yeah, one stays. And then the denominator of the second fraction is what? 25 comes out as the GCF and I have x plus y left. But I can cancel it out if anything. I can simplify 5 over 25 becomes what? 5 over 25 is 5 in the bottom or on the top? The bottom, right? 5 over 25 is 1 over 5. So what's left is xy on the top, and then 5 x minus y, x plus y on the bottom. So whenever you have the options here, right, and then the empty boxes, what is asked of you is to choose components of the final answer. So you kind of draft, right, Mrs. Osborne? Is that true? So whenever you have to fill in and you have some options, you're dragging this, right? So you take x and put it there. So x is used, and then y is used, and then 5 goes to the bottom, and then x minus y, or x plus y is 3. Questions? Okay. Division and complex fractions. So the division by fraction is the same as multiplication by reciprocal, right? So every time I see the division problem, very first thing that I want to do is rewrite it as the multiplication problem, and I don't forget to flip the second fraction. And then I do the same thing as before. If I see complex fraction, first thing I want to make sure that whatever crazy thing is happening in denominator and numerator, I want to make them single fraction. Single fraction numerator, single fraction denominator. Then I rewrite my complex fraction as the division problem, and then I rewrite it as multiplication problem, and I'm back to multiplication. Do you want to spend like 5 minutes doing the problems here?
Yes.
By yourself? Okay, so what do we have here? I have a fraction divided by a fraction. So that's how I'm going to represent the problem. Rewrite it as the division problem. Dividing by fraction is the same as multiplying by its reciprocal. Multiplying fractions is just multiplying numerators, denominators. 2 times 10 is 20, k. 5 times 6 is 30, k. K and k cancel out. 20 over 30 is the same as what?
2/3.
2 over 3.
What about the K? Oh, yeah.
K cancelled out. Questions? Okay, finally, in these set of notes, get all fractions to have the same denominator. Cross out denominator. Solve for x. If you get stuck, you can always work backwards by plugging in multiple choice answers. Remember to check for extraneous solutions. You will have the extraneous solutions in your multiple choices. Do not fall for that, right? If you are trying to plug in the choices back into the equation, what can happen is you have everything looks exactly the same, and you're like, yeah, that's it. But you have to check, is denominator 0? If it's 0, that's extraneous, right? Okay, so let's see. Let's do at least one of this together. Okay, so I have fraction plus fraction equals another fraction. All denominators are totally different. So let's look for the least common denominator. The first fraction has factor x in it. The second denominator has 3 factors, 3 and x, right? These are 2 different factors, 3 and x. And the third one has 5 and x. What is my LCD?
X.
I see that x is everywhere, so it has to come down just once. Then I also see 3 has to have it. And then I also have 5 has to have it. So my LCD, my least common denominator, is 15x. Now comparing my least common denominators, all these factors that I took down, with the denominators that I have, I'm figuring out what is missing. Yes?
I thought you said that for the LCD, you can only take 2 out.
No, I need to look at all the denominators that I have, and as long as my factor is existed in at least one of them, I have to bring it down. But if it exists in all of them, I just bring it down once.
No, but I thought that, like the circling and then you bring it down once, I thought that was only good for 2 of them.
No. Doesn't matter, you can have it plenty of them. All it means that I have to have that factor in denominator, but I don't need it twice or 3 times. It's already common to all of them, right? So that's why I would cut it out. So looking at my first denominator, I have x, but I don't have 3 or 15. So I need to multiply numerator by 15 and denominator by 15 to get my LCD. The second denominator is missing only 5. So times 5 times 5. And the last one is missing factor 3. So times 3 times 3. Now all of these denominators are the same, 15x. The numerators are 15x plus 13 plus 5x minus 13 equals 6x plus 27. I'm distributing them. So denominators can now be ignored, and my equation becomes what? 15x plus 5x is 20x. 30 minus 30 is cancels out, equals 6x plus 27. Minus 6x minus 6x on both sides. I have 14x equals 27. Divide by 14, divide by 14, and my answer is x equals 27 over 14. Questions? Let's not do the last one. It seems pretty easy, right? What is my LCD for the last one? 3x, right? So I'll have to multiply the first fraction by x and the two others, 3 and 3. Do we need to do this? No. Okay, now second set of the notes, exponentials and logarithms. Okay, exponential functions. The overview of the parent function. Function family, exponential. What is the parent function for exponential function? Jaden, what is the parent function? What is it?
Y equals 1 or
Exponential. Where is my x?
Exponent.
In the exponent. So how do I write this?
Dx.
I need some kind of base. Let's just pick the base 2, whatever, so we can graph it. But for any exponential function, the parent function will have the same base, right? Base can be different. 10, e, 1 over 2, 3, whatever. But the base has to be positive, right? Remember?
Why is that? Why?
Because you cannot graph with the negative. Think about it. You'll always change sign.
okay, not 1x?
1 to the power of x? Well, it's just one linear horizontal line, right? Kind of, what is the word? Okay, now let's graph it. 2 to the power of x. Here's my graph. Okay, so graph right. 2 to the power of x. Let's see how it looks. I mean, most of us remember? No? Just... Okay. So I'm not going to graph it here. You can graph it. Just make sure to note everything that is interesting about this function and then take some of these good points down, right? So for this one, what do I see? First of all, do I have an asymptote? Horizontal or vertical asymptote?
Yeah.
Yes, I do. Which one?
Got it.
Horizontal.
Got it.
Oh, okay.
And why do I know that I don't have vertical asymptote? Because I can take 2 to the power of negative 10, 0, positive 10. There are no restrictions on x. No vertical asymptotes here. But because I can never get negative number out of here, whatever x I choose, I'll never get negative. That's why we have that like restrictions on the range, right? My graph lies or lives above my asymptote, right? So here is my horizontal asymptote. So when you are graphing something, make sure that you figure out what your asymptotes or vertex are, and then a couple of good points.
So is it y equals 0?
Yes, for this one it is. Horizontal asymptote, for parent, it's y equals 0. It's very nice. Parent functions are very nice. Everything around 0. And there is no vertical asymptote. Okay, so what is my domain? You don't have any restriction on domain, no vertical asymptote. So, negative infinity, positive infinity. I could also write this in Builder notation. X equals what? Anything. Right? X belongs to real numbers. Anything goes. What about range?
0 to infinity.
0 to infinity. It lives above my asymptote. 0 to infinity. With parentheses, not brackets, because we don't include the asymptote value. What is my 0 for this function?
9.
None. It does not cross the asymptote, which is also x axis. So non-zero, none for x-intercept, because we know they're the same. What about y-intercept? Do I have y-intercept?
Yeah, it's 0, 1.
0, 1. This one. 0, 1. If I cannot clearly see it from the graph, I could do what? I could evaluate the function for x equals 0, so 2 to the power of 0 is 1, right?
Oh.
And then I could also look in my table and see the value for 0. So 0, 1, right here. Okay. Intervals of increase. Is my function increasing or decreasing?
Yes, it's increasing.
Increasing. As I travel from left to right, I go up. So it's increasing everywhere on its domain. So what is it?
0 to 100? I mean, 0 to
Increasing
infinity.
everywhere on the domain. So I always copy domain. Negative infinity to infinity, right? The increasing and decreasing intervals are all about x values. Where is my function increasing? Everywhere on its domain. Decreasing interval? None. Is this growth or decay function?
Growth.
Growth function. How do we know?
It's going away from the
It's going away from the asymptote on the right. On the right, it's going away from the asymptote. And also the base is 2, which is greater than 1, right? So this is growth. Either look at the base or at the graph. Base is 2 greater than 1. And graph goes away from t equals 2 greater than 1. And graph goes away. Okay, and behaviors. As x goes to negative infinity, I go to the left, what happens? 0. My horizontal asymptote. As I go to the right,
Infinity.
infinity. And again, if not sure if there is something weird going on, how can I figure out what my asymptote is? I will know that if my left behavior is stuck at some kind of number, that's my horizontal asymptote, right? Okay, so I can go in the table and scroll all the way up, see where I'm stuck. Any questions about this? Okay, let's do the examples. What are the asymptotes of this function? Okay, you can do the graph using calculator first. Or you could just apply transformations, right? So let's look at the transformations. What is my parent function for this one?
Y equals
Yes, I keep the base and then the simplest one. So what are the transformations?
right 4,
Since I'm replacing x with x minus 4, that means right 4,
Up one.
up 1, and straight. So now let's think about it. If my parent function looks like this, with the horizontal asymptote at y equals 0. If I'm applying these transformations, which transformations will affect my horizontal asymptote?
Up one.
Only up 1. It doesn't matter if I move the graph right or left, right? I'm still at the same height. It doesn't matter if I stretch these values, they're still positives and just like going up, right? So the only transformation that affects my horizontal asymptote will be the up one. So instead of y equals 0, this is parent, right? Parent. What will be my new horizontal asymptote?
Y equals one.
Y equals 1. Very good. And as x approaches negative infinity, what is the end behavior of this function?
0?
One.
It will come to the
Oh,
asymptote, right?
sorry.
It will be 1. So f of x equals 1. And if I forget about transformations, if I go to my graphing calculator and enter this function, right, what will I see? 3 times, so 3 times 2 to the power of x minus 4 plus 1. Here's what I see. So again, if I'm not sure if this is a fraction or what the hell is it, I just go to second graph to see the table, and then I go up to see what my left-hand behavior is. You see how I'm getting, my x goes to negative infinity and I'm getting stuck at 1. Right? So that's my left-hand behavior, so it has to be the asymptote. Right? So, questions? Here's the transformation. It's almost the same as we just did now. What is the parent function for this function?
Y equals 2 to the power of x.
Keep the base.
Oh, 7.
7 to the power of x. So what are my transformations?
Right 1 up 2.
Perfect. Do we all see this? What is the 0 of this function? Okay. How do I find the 0? I could go to calculator, graph it. What can be problematic here? What is my transformation?
It's very big.
Down 138. So I'll probably not see the graph in my window. Then it'll freak out a little, right? So either graph it and then zoom out so that you find the graph and where it is. Or you could do this algebraically. So how do we do this algebraically? When we find 0, we do what? Set the whole thing to 0. So 3 to the power of x minus 138 equals 0. How do we solve this? Plus 138 plus 138. We have 3 to the power of x equals 138. How do I solve this? What do I do? X rooted. Well, that's kind of weird, right? No, I don't know how to x root something. So what do I do? What is the inverse of
Log.
x? Log. I change this to log form. So how do we change this to log form? We keep the base, right? So I have log, I keep the base 3. What is the argument for the log function?
base 3, 138.
138. I switch the input and output equals x. So how do I evaluate now for the x? Biggest most. So log 138 divided by log 3 will give me my answer for x. If you enter this into calculator, carefully paying attention to how your calculator is using parentheses. Log of 138 divided by 4.8. 4.48, sorry. 4.48. Yep. Perfect. Yeah, it is kind of weird. Just if you don't see your graph in the calculator, probably the problem is meant to be solved algebraically. You can still solve it graphically, just you need to zoom out, find the part of the graph where you need to look.
Since you scroll the table to take data for the
You can, but see, you need to know where to scroll, right? Like where to look. No. All you need is 4.48, right? So in the table you will not even see this because this is fraction for x. You will see 4 and you will see 5, right? So you will not be able to figure this answer from the table. You need to actually see it on the graph and find the intersection. Well, for this one you will because it's at the 4. So you will see the graph will look something like your table, like on the graph. This is the window for your graphic calculator, and the graph will look something like this. Right, so you will see the 0, but you will not recognize the shape. It will look like a line, right, because it's somewhere down there and grows very fast. So it will be just weird looking. If you know what you're looking for, then good. If not, yeah, then you'll freak out. Or why is the line? Okay, next one. Oh, yes. Right. Well, these are also different ones. Do you know how to solve these? Horizontal asymptote we know, right? Transformations. What about this one? How do we solve this? I have two different exponential functions on two sides of the equation, so I can solve these by changing the base. Setting the base to the same thing. So 27 is 3 to what power? 3. And then I have this x, right? And then equals to 3 to the power of 2x minus 4, agree? And then yes, 3x equals 2x minus 4. Solve for x minus 2x minus 2x on both sides. I have x equals minus 4. If I don't remember how to do this, what can I do? I can do this graphically. Remember, I can use the left side and the right side and graph two functions. One will be like this, another one will be like this. Graph them, find the intersection. Remember we did this? Okay, oh my goodness, 5 minutes. No. Say again.